Hey guys, welcome to my channel and today I'm recording 5070 paper 2 theory paper of chemistry, Cambridge O level. This is May June 2021 paper. I've already solved its part 1. You can check it out. I'll put the playlist link in the description below. So without any further ado, let's continue from where we left the last time. That is, we did question number 2 completely. Question number 1 and question number 2 is solved. Moving on with question number 3. There is a concern about disposal of plastics made from non-biodegradable polymer. Part A says the partial structure of non-biodegradable polymer is shown. Part 1 says name the type of polymer shown. Since we do not have water being formed over here, so of course this is an addition polymer. Alright, moving on to part 2, draw the structures of the monomer used to make this polymer. The structure of monomer used to make this polymer is pretty simple. We just need to look at it. That is this much part, and we'll create a double bond in between them. So that's how I explained you in short. You're not going to draw this or this. Alright, never mind. Let's just draw it to give you a clearer image. We have H over here, hydrogen, and then we have C over here. Then we have CH3, Cl. Oh god, why is it? Alright, so continuing, we have Cl here and H. Alright, quite not very neat, but I hope you guys understood it. Moving on to part 3, the polymer is often disposed of by combustion. Suggest one problem associated with this method of disposal. Combustion means burning. Burning means, uh, burning causes produces carbon monoxide, which is a poisonous gas. So we can write that it produces poisonous gas, which is very harmful. So moving on to part B, lactic acid is used to make polylactic acid as a biodegradable polymer. The structure of lactic acid is shown. Suggest what is meant by the term biodegradable. Biodegradable is are those kinds of materials that can be decomposed naturally. Those are biodegradable materials. Since we have the word bio, which is about life, natural things, degradable, decomposition, and all. So, quite understood. Moving on to part 2, draw the partial structure of polylactic acid. Show at least two repeat units. First of all, you need to know lactic acid and then you're going to draw its polymer. Alright, so it's going to be. Alright, so this is how you're supposed to draw it. I hope I have drawn it completely right. So this is one structure you need to draw over here as well. These are two repeat units basically shown here. One repeat unit and the second repeat unit. Alright, like one unit and the second unit. That's all. Moving on to part 3, a factory uses 5,000 tons of lactic acid to make polylactic acid. The percentage yield is 100%, but the mass of polylactic acid is made it's less than 5,000 tons. Sorry, 500 tons. Explain why the mass of polylactic acid made is less than 500 tons. Because a very good question. This is a very nice question. Although the yield is 100%, yet the mass is lower because although 100% of product is formed, but when we're talking about the reactant product, the reactant and then the product, reactant has H2O part in it too. However, it's a condensation polymer, so water gets separated out. That means it is reacted in such a way that water H2O comes out of the reactant part and together it forms water, while the rest of it becomes a part of polymer, hence its mass automatically decreases. Moving on to parts 4, aqueous lactic acid reacts with acidified potassium magnate 567, potassium magnate 7. So there is a color change from purple to colorless. Suggest what happens to the lactic acid in this reaction. This is basically an oxidation reaction because we are looking it from purple to colorless. So you can write that lactic acid has been oxidized. Moving on to part 5, aqueous lactic acid is neutralized by aqueous sodium hydroxide. Write the ionic equation of this reaction. If we write the ionic equation of this reaction, it's going to be something like this because it's a neutralization reaction. And it will form water. Moving on to part 6, aqueous lactic acid reacts with magnesium. Name the gas made in this reaction. In this reaction, we will see lactic acid with magnesium, hydrogen will be formed. Alright, so this is basically the types of reactions that we study in organic reaction chapter, where we talk about acids and its reactions. So you need to thoroughly go through all the reactions. Moving on to question number 4. Question number 4 says zinc bromide and zinc carbonate are both ionic compounds. Predict two physical properties other than electrical conductivity of zinc bromide. We know the characteristics of zinc bromide, that is, it is an ionic compound, and because ionic compound can conduct electricity, one of it is already given over here, that is electrical conductivity. We need to figure out two more properties, two more physical properties, not chemical properties. So physical properties can be they're soluble in water. All the ionic compounds are soluble in water. Then they have high melting point. Can be a great physical property to mention. So these are two physical properties. You can also mention that they are insoluble in organic solvent. I don't mean you can also, but however, if any from out of these three, you can mention any two of them. So moving on to part B, zinc reacts with bromine to make zinc bromide. Zinc plus bromine and zinc bromide is formed. Alright, so zinc bromide contains Zn 2 plus and Br minus. We see the reaction over here. Explain in terms of movement of electrons how zinc bromide is formed from zinc atoms and bromine molecules. So if we see zinc has positive ions and bromine has negative ions, bromide basically has negative ion. So zinc will lose its electron and then bromine gains the electron. Since has the ability to lose two electrons, so two bromine will be involved in this reaction. That means uh, zinc will give away its electron to two bromines, and bromine will accept two of the electrons, hence forming ZnBr2. That's all. You can frame it into a nice proper answer and write it over there. Moving on to part C, aqueous zinc bromide reacts with magnesium as shown. Part 1 says use the equation to explain the oxidation that takes place. Okay, explain that oxidation, sorry. Use the equation to explain that oxidation takes place. Alright, so Zn2 plus Mg, Mg2 plus Zn. We need to use this equation, means we need to take elements from this equation and explain that oxidation is happening. How can we do that? If we see over here, magnesium is losing its electron, alright, and it is gaining, and the oxidation state is increasing. That is why oxidation is taking place with magnesium. You do not need to mention anything about zinc since it's not being oxidized, it's being reduced. Moving on to part 2, use the equation to explain the reduction that takes place. Since here we're talking about reduction, we are going to mention zinc, the oxidation number of zinc is decreasing, hence reduction is taking place. And why is it decreasing? Because um, zinc is basically gaining electron, that is why its oxidation number is decreasing. Moving on to part D, zinc carbonate is insoluble in water. Zinc carbonate can be prepared by reacting aqueous zinc bromide with CO3 minus aqueous ions in a precipitation reaction. Name a suitable aqueous solution that can provide CO3 minus aqueous ions. We can write over here sodium carbonate can be a suitable aqueous solution. You can write many other, like for example potassium carbonate, but over here I just mentioned sodium carbonate. Moving on to part 2, a sample of zinc carbonate is heated strongly. Name the products of this reaction. Now you need to be very focused on the word heated strongly. That means full combustion is going on. It is fully being oxidized. It's fully being heated. That means zinc oxide will be formed. Alright, I'm sorry. It's not combustion at all. It's not combustion. I take that words back because combustion leads to carbon dioxide and water. However, we are still talking about strong heating. That means it's fully being heated. So zinc carbonate plus uh, zinc carbonate, when heated, it will of course form zinc oxide and carbon dioxide, because we are talking about heating strongly again. It will be carbon dioxide. So this is it for this video. Thank you so much for watching. If you have any queries, you can put it in the comment section down below. And best of luck for your exams.